Welcome to This Explainer. When most of us picture flood defense, we tend to imagine this massive, magical wall just holding back the ocean. But as we'll see from our sources today, that's actually a total myth. Instead, we're going to dive into local infrastructure, specifically on the North Shore, to uncover how modern flood mitigation is actually a living, breathing, and highly dynamic system.
So let's kick things off with a pretty crucial question. Why does flood damage rarely come from just a single cause? Think about it for a second. It's almost never just a river getting a little too high, right? Usually it's intense rainfall colliding with saturated ground and high tides all at once. Because the threat is essentially a multi-headed monster, our response has to be one too. And that brings us back to that single giant levee or seawall idea. It's a really pervasive myth. The reality is, effective flood control requires coordinated action across miles and miles of terrain. You have to catch the runoff upstream, you've got to reinforce the shoreline, and you absolutely have to manage the pooling in low-lying neighborhoods. It's a distributed network. It's a team effort, not a solitary shield. All right, let's move on and look at the 4 core flood strategies. Literally every modern system you'll ever see steps systematically through these 4 pillars. They act like a sequence of defense mechanisms. First, slowing the water down, then storing what you can't slow, redirecting what you can't store, and finally, protecting against whatever is left over. Let's break down how this actually works out there on the ground. The very first line of defense is simply hitting the brakes. If millions of gallons of water rush in all at once, the system is instantly overwhelmed. There's no way around it. So engineers use specific grading, special channels, and flow control devices to deliberately ruin the water's momentum. The whole goal here is just to stretch out the clock.
Next up is storage. When slowing it down just isn't cutting it, the system acts like a giant sponge. It temporarily holds the excess water in retention basins, which honestly you might mistake for a local park, or even in these massive hidden underground tanks. You could literally be walking over millions of gallons of stored floodwater right now without even knowing it.
Finally, we redirect and protect. Redirecting gives water a safer path of least resistance, physically pushing it away from our homes. And when all else fails during a really extreme event, that's when you enter the protect phase. This is where you deploy those hard physical barriers, like seawalls and levees, to shield the absolute most vulnerable zones. Now let's explore how these systems switch modes under pressure. Because these strategies, they aren't static. They adapt in real time. Under normal conditions, water just flows happily through storm drains. But as water rises, the system shifts. It deploys gates to actually stop backflow from the ocean. If the capacity is exceeded, it shifts again, this time into emergency storage. And finally, the post-storm phase kicks in for a highly controlled drain.
Now, the climax of the event happens when standard capacity is completely maxed out. Gravity is absolutely no longer your friend here. The system has to flex its muscles using heavy-duty pumped systems that actively force the water out to safer discharge points. It is a massive, incredibly energy-intensive fight against nature.
And here's a fascinating takeaway from our sources. The work doesn't just stop when the sun comes out. That gradual draining phase, it's an intense balancing act. Operators have to carefully, methodically release the stored water. If you release it too fast, well, you just flood the downstream neighbors. But too slow, the current neighborhood stays underwater.
Let's ground this theory and take a look at some real-world North Shore infrastructure.
To really picture this, let's look at how this hardware actually exists right now in North Shore communities. You have retention basins to catch the rain, tide gates to block the ocean, and heavy-duty pumps for the low points. The real genius here is redundancy. Basically, if a record surge overwhelms one layer, the next layer steps right up to share the burden.
What's vital to understand here is how the system tailors its response to the specific threat at hand. A heavy rain event mostly tests the local drainage and retention basins. The system is essentially fighting water falling from the sky. But a high-tide coastal surge totally flips the script. Now the pressure is heavily on those backflow preventers, tide gates, and sea-facing barriers to keep the ocean from pushing its way in.
Which brings us to a really crucial part of the puzzle: maintenance and active operations. It turns out, surprisingly, the greatest enemy of multi-million-dollar engineering isn't always a massive hurricane. Sometimes it's literally just weeds and dirt. Sediment fills the channels, debris clogs the inlets, and wild vegetation blocks the flow. Rigorous, Everyday cleaning is just as vital to community survival as the concrete itself. It's not glamorous, but it is absolutely essential. And we absolutely can't forget the human element in all of this. Today's operations staff, they aren't just out there turning rusty cranks. They're sitting behind real-time sensors and advanced forecasting models, making high-stakes, split-second decisions on exactly when to open a gate or fire up a pump before a neighborhood floods. They are the brains of the operation. All of this leads us to an important concept: risk reduction, rather than risk elimination. We have to be realistic here. We can't just put our homes inside a magic waterproof bubble. Zero flooding is an impossible guarantee. The actual engineered goal is risk reduction. It's about minimizing how often the water reaches your doorstep, minimizing how deep it gets, and ultimately how fast you can get your life back to normal after a storm hits. And this leaves us with a really powerful takeaway from our sources today. True resilience isn't a static, immovable wall. It never was. It's an active, interconnected, and incredibly well-maintained network that slows, stores, and redirects the water in real time. So I want to leave you with a provocative thought. As climate conditions shift, bringing heavier downpours and higher sea levels, nature is actively changing the baseline. The question isn't just about the infrastructure you have today. It's about how your community will engineer its next layer of defense as the water continues to rise. Thanks for joining me for this explainer, and we'll see you next time.